Today's lesson, section 3.3b, we're going to continue dividing polynomials. And so example 5 wants us to find all the zeros of the given polynomials if one of the factors is given. So like letter A, you're given that negative 1 gives you a y value of 0, so that means that negative 1 is a factor. So if I use my synthetic division and just write negative 1, so here since it's already solved, so that's what x equals, I don't have to solve it or change the sign. And so now I put in my numbers, so 1, 2, negative 5, negative 6, and then use my synthetic division. So add down gets me 1, multiply gets me negative 1, add down gets me 1, multiply gets me negative 1, add down gets me negative 6, multiply gets me 6, and then add down gets me 0. So it is a factor, like it said it was, and so now we know that negative 1 is a 0, for sure. And now I want to rewrite this polynomial here. So you get x squared plus x minus 6. So then now I want to be able to factor this or solve it in any way I possibly can. And so I want to set this equal to 0. And since this is a trinomial, I can factor it. And it looks like it does factor. So if I split up the x's, and then factors of 6 that subtract to get me a positive 1 would be a positive 3 and a negative 2. So now I solve for both of those. So then that would give me x is equal to 3, x is equal to 2. So now all my values would be negative 1, which is the first one we found or was given, and then negative 3 and 2. So those are all my zeros. Example B, similar. Here they say that 1 is a factor. Now notice that you have x cubed minus 7x plus 6. You're missing the coefficient for the x squared, so you'd say 1, 0, negative 7, 6. Okay? Add down, get you 1. Multiply, get you 1. Add down, get you 1. Multiply, get you 1. Add down, get you negative 6. Add down, or multiply, get you negative 6. And then add down, get you 0. So here, it looks like we're going to have the same polynomial just by happenstance. Okay, set it equal to 0. Factor, so I get x minus 2x plus 3. Set them both equal to 0 and solve. Okay, so then x will equal 1, 2, negative 3. Okay. Example 6 says that we want to find the polynomial of a given degree with the given zeros. So here they say that degree is 4, and zeros are negative 3, 0, 1, 5. Okay. So they're telling you put them in. So you should have a degree, or the highest degree should be 4 in the end. And so since you have 4 answers, that makes sense. Now you want to be able to write these so that you can create a polynomial. So you want to put these back in because these are all equal to x. So you want to rewrite them as if you wanted to be set equal to 0. So then doing that would get you x plus 3, and then x minus 0, and then x minus 1, and then x minus 5. Okay? And that should equal your polynomial. Now, for the x minus 0 one, you could just write x if you'd like. And so now you want to multiply your numbers through. So let's do the first two. Gets me x squared plus 3x. Gets me a binomial. Okay. The second one gets you x squared minus 5x minus 1x plus 5. And then simplifying gets you x squared minus 6x plus 5. And now I want to multiply that through, so x squared times x squared gets me x to the 4th. X squared times negative 6x gets me negative x to the 3rd. X squared times 5 is 5x squared. 3x times x squared would be positive 3x cubed. 3x times negative 6x would be negative 18x. And then 3x times 5 would be 15x. So I want to add like terms. So that gives me negative 3x cubed minus 13x plus 15x equals your p of x. Okay, so then here's your polynomial. Okay. Next one, you have a degree of 3, so then I only have 3 answers here. So I want to do the same thing, write my binomials. Remember that they need to be opposite of what they are. Okay? And then choose 2 to multiply first. Let's do the first 2. So I get x squared minus, or plus 5x minus 4x minus 20. Okay? Simplify, so x squared plus x minus 20. And then multiply the other one through, so x cubed minus 2x squared, and then x squared minus 2x, and then negative 20x plus 40. So here I want to add down, so x cubed, negative x squared, negative 22x plus 40. Okay, so there's my answer. So that's what they're kind of looking for when they want you to find a polynomial. Okay. Now the next thing we want to talk about is going to be in section 3.4, and so we're talking about the rational zero theorem. So if a polynomial has integer coefficients, and then every rational zero of p is, so capital P, so the polynomial is the form of p divided by q. Now p represents the factor of the constant coefficient, a sub 0, and q is a factor of the leading coefficient of a sub n. So what this theorem is telling you is it's giving you an ability to create a list of possible zeros that are rational, so meaning they're fractions or couldn't be written as fractions, and so any one of them could be a possible solution or a zero of your given polynomial. So what they want you to do first is identify what p and q are. So remember, p is the constant, so that would be the 2 in this case, and q is the leading coefficient, so it would be 3. So now I want to be able to write my factors in the form of p divided by q, and so now you get 2 and 1 for the numerator and 3 and 1 for the denominator. Okay? So in this case, I want to be able to list all the different factors, so it's looking at all the different combinations. So you can get 2 over 3, you can get 2 over 1, you could get 1 over 3, and you could get 1 over 1. Okay? Now for all of these, you want to be able to reduce them, and both the positive and the negative of each factor is possible as well. So it gives me a plus or minus 2/3, plus or minus 2, plus or minus 1/3, and plus or minus 1. It doesn't matter if it's in an order or anything. So you just need to list them all. Okay, so here, now I need to be able to find a zero that works. Okay, so at this point, it's a little bit of a guess and check game using synthetic division. So you're going to have to pick one that you think might work, might give you a zero for your remainder, and then go from there. Because then it should break it down into a trinomial of a quadratic equation, and then you can probably factor it from there. Okay, so let's go with, I want to see if 1/3 works. Okay, so I put my coefficients in here. So 3, -4, -5, and 2. Okay, so I want to add down, multiply. So 1/3 times 3 is 1. Then add down gets me -3. 1/3 times -3 gets me -1. Then -5 plus -1 is -6. So multiply to 1/3 gets me -2. And then 2 plus -2 is 0. So it is a factor, yay. Okay, so then that's 1. So then now let's use this new polynomial that I've got. So 3x squared minus 3x plus, or sorry, minus 6. Okay, let's set that equal to 0. Now here, everything is a factor of 3 in it. So let's divide everything by 3 just to move it out of there, because it doesn't really matter. So then that gets me x squared minus x minus 2 equals 0. Okay, now let's factor. So split your x's. Now factors of 2 that subtract get you, well, negative 1 would be negative 2 and positive 1. So it looks like it does factor. And then I want to solve. So your 0 should be 1/3, 2, and negative 1. Okay? Let's try another one. So here, this is my P, this is my Q. So factors of P is 5 and 1. Factors of 2 is 2 and 1. So let's make a combo. So 5 over 2, 5 over 1, 1 over 2, 1 over 1. Okay, so then simplify. So 5 halves, plus or minus 5, plus or minus 1 half, and plus or minus 1. Now another key to this is, one thing you might want to remember is that usually the smallest numbers work, or are going to work more likely than the bigger ones, just because usually with the bigger ones they get so large, like when you're doing synthetic division, that you will obviously see that it's not going to become 0. Okay, so like 5, I probably wouldn't try that first. I would try my other numbers. So here, let's try 1. Okay, so 2, negative 5, negative 2, 5. Okay. Now also, another key thing with this, even though I got like 3 answers up there, if I would have tried any of those, I would have still gotten 0 with that first one. So it doesn't matter which one you pick first. They're all going to work no matter what, which is nice. So you don't have to like get the perfect right one to begin with. You can get any of them, and they're all going to work the same way. It's just that your factoring will look different if you choose a different one than your neighbor. Okay, and you both are correct. So add down gets me 2, multiply gets me 2, add down gets me negative 3, multiply, add down, multiply, add down. So that's a 0. So you get 2x squared minus 3x minus 5. Set that equals 0. Here, there's no common factor. So let's try to work this out. So I want, it's got to be 2x and x. Okay. I need factors of 5 to match up with the 2 and the 1 to help me get a negative 3. And so that's got to be, your 5 and your 2 like subtract by themselves to get 3. So if you put them together, because you want a negative 3, and the other one's away, then it'll make it easier. So check your work. So 2x times 1 gets you 2x. Negative 5 times x gets you negative 5x. So negative 5x plus 2x gets you negative 3x. Okay, so then that's what you want. So now split it up. Okay, so then all my answers are right there. So I got 1, negative 1, and 5 halves. Okay, and that's it. Have fun.